Hi everyone, Zoe here. I am the other half of Mir.Works. I'm usually behind the scenes, editing videos and planning what content we're going to be working on next. I've been collaborating with Matthew the past couple of years, teaching workshops, and most recently we started this initiative, Mir, super exciting. And we shared a tutorial on how to create a faux refraction and reflection technique. You can find the tutorial for that on Mir.Works. We post all of our tutorials on our blog. Here you go, very handy, very exciting. I'm a fan of all that is kind of crystalline and refractive. If you don't know, we made an Instagram, so you can follow us there. We're going to be posting more of our work here. I'm online, I'm Radial Balance, and recently I posted this video of an illusion using the refraction technique to essentially hold this magical crystal in my hand. And some folks commented and were wondering what technology this was. Someone asked about Spark AR. Other folks were asking if we could do a tutorial or workshop about this. And so I thought that it'd be a good idea to do that. I've used the Leap Motion a bunch in my own work and in my research. I've just finished my master's and I did a lot of work with the Leap Motion. That's what was used for this. And so what we're gonna do today is a tutorial on how to create this effect. It's pretty simple. It's essentially a 2D illusion. And yeah, we'll get to look at that. So the Leap Motion, if you don't know, is a gesture tracking sensor. Predominantly it's used in VR, mounted on headsets, or integrated as an alternative device for detecting gesture. It's pretty tiny. It's about 3 inches, really shallow. I've embedded it in a bunch of different kind of fun materials as a way to kind of do more nuanced sensing, if you will. And so we're going to be using this today. You can buy it online. Apparently on Amazon. It's coming soon. I got it on Amazon. It's pretty cheap. I think it's like just over $100. I mean, it's such a small sensor. I definitely recommend working with it. It might even be $80, honestly. You check. It's pretty great. Apparently they're coming out with more stuff. Very exciting. So what we're going to look at today is working with the Leap Motion in Touch Designer specifically. I did a little bit of research and I saw that Light Notes put together this tutorial on how to do some kind of like hand and finger tracking, and you get to have this like super fun kind of simulation and visualization of a hand. So I'm going to be doing something similar to that, but less of a visualization. Oh, look, it's my face. Less of a visualization of the hands themselves and a more kind of abstract approach. And so what I have created here are magical rainbows. Because like, who doesn't need rainbows in their lives? I've like had to modify this to like fit this like wonky webcam, which is a big part of trying to create this illusion, as you saw in the other video. And so yeah, we're gonna take a look at this and how to make something like this. Down here you can see just the 5 points for each of the fingers. Ooh, it's a little wonky. So we got thumbs, we got index fingers. Oh, there we go. Index fingers, ring fingers. Yeah, you get it. We're gonna do some finger tracking, and then we're gonna do the refraction technique, the like kind of holding a refractive orb in your hand. All right, so we're gonna close out of this thing and we're going to open a new Touch Designer project. You know, I'm gonna save just in case. I'm gonna close this. And the first thing we're gonna do is we're gonna go ahead and look at what the Leap Motion data even is. So after we've deleted everything, we are going to add a base component. And so I'm going to name it base underscore leap data. And this essentially is going to be the home for our data so that we don't have it kind of mixed in with our render pipeline, and we have everything nicely and neatly organized. So I'm going to hop into the base leap data I just made. And the first thing I'm going to do, I'm just going to look at what the Leap Motion camera, what its imaging is. So I'm going to use the leap top. I typed in top. Leap top. Okay. So as you can see, it's pretty wide. My head is super tiny and my hands are enormous. The field of view for the Leap Motion, I believe, width-wise is 135 degrees. It's pretty wide. I'd say you get about 3-ish feet across and about 2.5 feet high. You can go a little bit further, but your tracking definitely starts to lose some of its fidelity and consistency. And so I'm going to go ahead and delete that because we don't need it. I just wanted to show you what the camera looked like. But what we are going to use is the super handy Leap Motion chop. Look at that. So if all went well in your kind of plug and play install process of the Leap Motion, it's pretty simple. I'm not going to go through that. There are some helpful applications online on the Leap Motion site. But if it all worked out, you should see what I see here, which is some fun data. At the top, you'll notice that there's the serial number. Here we have the field of view. The vertical field of view is about 115 degrees. There's a lot of data in here, and sometimes when you're far away, you can't really read it. And so what I tend to do is I tend to turn off the device info, the debug channels, the status channels, just to minimize the amount of channels that there are, just because it is a lot. And I like to add the 5 fingers. And now, right now there's even more channels, but at least I just have kind of the finger data. And as what you'll see is that as I get close to the sensor, the values go down up until about 4 to 5, 6, about 5 to 6 inches, and then it kind of disappears. But then as I move my hands further away from the sensor, we get really high positive values. And so we're gonna go ahead and select out some of this data to start messing around and creating that rainbow effect before we go into the refraction example. And so I am going to add a select chop. I'm gonna add a select chop. And what I'm gonna do is I'm gonna put it side by side. I'm gonna display it. I believe it's here on the right. And what I wanna do is I really just want the data that has the finger information. I don't need anything else right now. And so on channel names, I'm going to keep the star, the asterisk. Essentially that means give me everything. I would like all of the channels. I want just finger. So what I did is I typed in the word finger and then I added another star because I want to just see all of the finger information. And now, thankfully, my channels have gotten smaller, even smaller, which is great. I'm going to close that. Now, I don't need all of these channels. I really just want the position value. So that is the TX, TY, and TZ for each finger. So what I'm going to do after this star is I'm going to open bracket and I'm going to go 0 through 4 because I want the 5 fingers. Note that 0 is a position here, so we see 0. We don't do 1 through 5, we do 0 through 4. And I'm going to do a colon, and I want just the values T, X, Y, and Z. And what you see is now we only have T, X, T, Y, T, Z. What happened here is I'm using pattern matching. And so essentially I want everything up to finger, and then I want each of the fingers 0, 1, 2, 3, 4, and I want only the values that say TX, TY, TZ. Great. Exciting. The next thing that we're going to do is we are going to shuffle these channels. The shuffle chop, let me just hover over that one more time. The shuffle chop reorganizes samples in a set of channels. It essentially groups them so that you have them kind of all together in one sequence. And so what I'm going to do is I am going to shuffle, I believe, every nth channel. Yeah. So what happens, I'm going to like hide this friend. What happens now is that all of the TXs are together, all of the TYs are together, and all of the TZs are together. You can notice it the most in TY. So TY is the height. And so as I raise my hands up, the value for TY goes up and then it goes down as I get closer to the sensor. This will be super helpful just for instancing the individual finger positions and having all of the data together in one place. Great. The next thing that I'm going to do is I am going to add a null. And we will be done with kind of our initial pass of setting up our data. It's not a lot. I know you're like, why did we put all of this stuff just in one base? Honestly, once it can get pretty chaotic really fast. And so this is a really simple example, but I just like keeping my networks organized. So I'm going to keep this leap data here on the left. I split my panes using this little handy feature. And I'm going to create another base next to the leap motion base. And what this is going to be called, it's going to be called base rainbow trails. Great. Now what I'm going to do is I'm just going to select that null. Oh, wrong one. I'm going to add a select chop, and I am going to drag that null over. We don't need the rest of our data for now, but I would like to maintain I want to be able to go back to my leap data. So I'm going to click this full screen mode. Essentially what this does, if you haven't used it, it kind of lets you save your other segmented workspace and just kind of work in one of the panes. Cool.